In this third video, I'm going to show you how to split a separate diagonal force unrelated to the slope angle into components. If you haven't watched the first video, which gives more detail on how to set up the diagram, it would be helpful to watch that first. So imagine we're given a question where the angle of the slope is 30 degrees and we're told that the angle between a tension force, a string pulling the object up the slope, so the angle between that and the slope is 40 degrees. So that means that the angle of the slope is here, and if I draw a line parallel to that here, the angle between that and the tension is 40 degrees. So sometimes students are confused. They think these are related. They think that maybe you have to add these two together to give 70 degrees. That's not the case. You can just zoom in on this as if it's on its own on a diagram and just split up the forces. If it helps, you can turn this so that it's horizontal in your eye line, but I'm just going to put it back like this. So the first thing to do again is to put the ruler parallel to the slope to draw the parallel component, and I'm going to draw that like this, and then turn the ruler so that it's perpendicular to the slope and the end of the ruler is touching the force at the other end, and draw a perpendicular component which obviously should be at right angles to the parallel component. Remember that the right angle should never touch the force. If it does, you get a diagram that looks something like this. We can see that what should be the perpendicular component here is not. This is perpendicular, this is not. And the right angle is touching the force, which is totally wrong. So just make sure the right angle doesn't touch the force there. And now all we need to do is write on the components. So the side opposite the angle is related to sine. So force T multiplied by sine of 40 degrees, and the side adjacent or next to the angle is T cos 40 degrees. And that's done. In my next video, I'll show you how to split into components the forces acting on a ladder. Just click the link below to watch. Or for a full run through of components on slopes and on ladders, click the second link that takes you to my playlist.